Given question, what should be the value of theta that will make the motion of 500 Newton block down the plane to impend? The coefficient of friction for all contact surfaces is 1/3.
We have to find out the angle theta of the inclined plane so that this 500 Newton block will start to move on the inclined plane. So we will show here the motion of the 500 Newton block. We will first draw the free body diagram of this 500 Newton and 200 Newton block. Now if we observe this 500 Newton block, then its lower surface is in contact with the inclined surface and its upper surface is in also contact with the 200 Newton block. So when it will start to move in the downward direction, then we have to show the frictional force in the opposite direction of the motion. Now this motion of this 500 Newton block is in parallel with the inclined plane. So frictional force also we have to show parallel with the inclined plane. So we have to show this 500 Newton block and 200 Newton block. Now we will show the frictional force. So frictional force for lower surface also and for upper surface also. Now for lower surface we will use here the suffix 2. So I will show here frictional force F2. And for upper surface we will show the suffix 1. So there is the same direction of the frictional force because the motion is in the opposite direction. So we will show here, and this frictional force is nothing but F1. Now this lower surface is in contact with the fixed surface, that is inclined surface. So normal reaction acts perpendicular to the direction of this surface. So we have to show one perpendicular line and direction is towards the block, and that is nothing but the normal reaction N. So we will show here one perpendicular line and it will be passing through the center of the block, and we will use here for lower surface suffix 2, that is N2. Now weight of this 500 Newton block. So weight always acts in vertically downward direction passing through the center. So we will show here in vertically downward direction, here is the weight and it is 500 Newton. Now we will move to the 200 Newton block. Now this 200 Newton block is tied with this inclined vertical wall. Now if we observe, here is the perpendicular, that means this inclined line and this vertical line both are perpendicular to each other, and this string that tied to this 200 Newton block is parallel to the inclined plane. So we have to show the tension in the string that is in the outward direction from this 200 Newton block, but this line is parallel to the inclined line. So we will show here. Now weight of the 200. So weight of 200 Newton block which will act in vertically downward direction passing through the center. So it is 200 Newton. Now this 200 Newton block lower surface is in contact with 500 Newton block. So motion of this 500 Newton block, if we observe in the downward direction, so frictional force in the opposite direction, that is F1. So F1 is the frictional force is for the upper surface, and the lower surface of 200 Newton block is in contact with the upper surface. So magnitude of F1 in between these two blocks is same, but direction is opposite. So we have to show same magnitude but opposite direction. So I will show here. Magnitude same but direction opposite. Now we have to show normal reaction. So normal reaction always perpendicular to the surface of contact. Now this surface of contact is inclined, that is it is parallel to this inclined surface. So we have to show normal reaction. Now for this upper surface we will use here suffix 1. Now both surfaces are in contact with each other. So normal reaction will act on the both surface. So we have to show normal reaction N1, and this reaction, the direction is towards the block. That is, for 200 Newton we have to show direction towards 200 Newton block, and for 500 we have to show direction towards 500 Newton block. So we will show here this is nothing but N1. So N1 for both, and here magnitude is same but direction is opposite. If we observe this diagram, all the forces are parallel to the inclined plane as well as perpendicular to the inclined plane except this weight, because weight always acts in vertically downward direction. So we will resolve this weight into two components. One component is parallel to the inclined plane and other is perpendicular to the inclined plane. So for this 200 Newton, I will show here one component. So this line is also parallel. So here is tension T. So this line is also parallel, and here this line is perpendicular, and we have to show direction. And for this 500 Newton also, one line we have to show parallel to the inclined plane and other is perpendicular to the inclined plane, and we have to show here direction. Now how to decide its a value? So for that, if we observe this inclined line and this horizontal line is having an angle theta. Now for this inclined line, I will suppose draw here one perpendicular line. And for this horizontal line, if I will draw one vertical line. Now these two lines are perpendicular to these two lines, making an angle theta. So here at the point of intersection, same angle is there, that is theta. Now here is, this is the vertical line which is perpendicular to the horizontal line, and for this parallel line here, this line is perpendicular to the inclined line. So angle in between these two lines, because here if I extend this, here is the point of intersection at the center of block. So here is same angle theta. Now in the same way, for 500 Newton block also the same angle is theta. Now how we can decide its a value? So for this component which is perpendicular to it, it is nearby to angle theta. So we can say that 200 cos of theta. 200 cos of theta. And for this component which is parallel to the inclined plane, we will say 200 sin of theta. Now in the same way, here also 500 cos of theta. 500 cos of theta, and here 500 sin of theta. Now we will move to the equilibrium of this 200 Newton block. Now we will consider summation of forces normal to plane is equal to 0. Now which are the forces which are normal, that means perpendicular to plane? So this component N1, and here is 200 cos theta. Now both are in opposite direction. So from the diagram we can directly say N1 is equal to 200 cos theta, or we can say N1 minus 200 cos theta is equal to 0. Now N1 is equal to 200 cos of theta. Now there is one relation in between this frictional force and normal reaction N1, and we can say that F1 by N1 is equal to 1 by 3. So what is this 1 by 3? That is coefficient of friction, and it is mentioned in the question. So F1, that is the frictional force, we can say 1 by 3 into 200 cos of theta. Now we will move to the next block, 500 Newton block. So when we consider the equilibrium of 500 Newton block, then the summation of forces normal to plane is equal to 0. Now from diagram, which are the forces normal to plane? So this is N2. So for this upward direction we will consider positive sign. So N2 minus N1 minus, for this 500 cos of theta is equal to 0. Now therefore N2 is equal to, now value of N1. So N1 is calculated from the previous 200 Newton block, 200 cos theta. So if we put the value, then N2 is equal to 200 cos theta plus 500 cos theta. So which is equal to 700 cos of theta. So we will underline this because we have to use this value later. Now we will move next. Now there is one relation in between F2 and N2, because F2 is the limiting friction and F2 by N2 is equal to coefficient of friction 1 by 3. So F2 is equal to 1 by 3 into N2, that is 700 by 3 cos of theta. Now we will move to the next, that is the summation of forces parallel to the inclined plane. So which are the forces parallel to inclined plane? So here is 500 sine of theta. So for this left hand side direction we will use the negative sign. So minus 500 sine theta plus F2 plus F1. So from diagram we have to write this statement is equal to 0. Now what is the value of F1 and F2? So we have to write this value in terms of theta, because unknown term is theta. So here is the value of F2 and here is the value of F1. So this 500 sine theta I will transfer to the right hand side. So it will become 200 by 3 cos of theta plus 700 by 3 cos of theta. So this cos theta we will take common term, which is equal to 500 sine of theta. Now this 500 I will transfer to the left hand side and this cos theta I will transfer to the right hand side. So sin theta by cos theta is tan theta, and when we solve this left hand side then we will get 0.6. So theta is equal to 30.96 degree.